Three modes of transfer of heats are there.
Excuse me,
Tell
sir.
me.
Sir, before you said this subject to paper, no, sir, we should write solutions for that, sir.
Yes, yes. Yeah, that is the descriptive exam, descriptive paper.
Total, sir.
Not total. So some questions are single correct, some questions are multi correct. For that questions, you can choose the answers. But
Okay.
for the section 3, so every year I think they are changing the paper pattern. So previous year they asked for 100 marks. Last before year they asked for 180 marks, like that. Clear?
Okay, sir. I said thank you, sir.
Three modes of transfer of heat energies. What is the first mode? Tell me. Conduction, convection, and radiation. Conduction, convection, and radiation. The heat transfer by the process of conduction mainly occurs in solids, whereas convection occurs in both the liquids and gases. Radiation occurs only in here. Conduction occurs in which place? Tell me. Conduction occurs only in
Solids.
solids. So convection occurs both liquids and gases. Radiation occurs only in gases. What is the process of transfer of heat from sun to earth? In which mode? In which mode of transfer the heat will transfer from sun to earth?
Radiation.
Radiation. So one by one we are going to check what is conduction, what is convection, what is the radiation. Conduction is a process in which heat transmitted from one part of the body to another part of at lower temperature by molecular collisions without transfer of intermolecular medium. What is conduction? Tell me. Transfer of heat by transfer of heat from one part of the body to one part of the body to another part of the body by molecular collision without transmitting, without transfer of the material medium. For example, let us suppose that you have one metal rod. One end of the metal rod is kept in flame. This is the flame. The other end is hold with your hand. So after some time, so are you able to hold the rod for longer time? Tell me. Are you able to hold the rod for longer time?
No, sir.
No. Why? Because the from the flame, the rod will receive the heat energy. As a result, its temperature increases. As the temperature increases, it hurts our fingers. Am I correct? So what happened here? Heat energy transfer through the rod from one end to other end without molecular movement of the rod. Rod molecules does not move while heat transfers from one end to other end. Such type of mode of transfer of heat energy is called. So how heat energy will transfer? Tell me. After receiving the heat energy, the molecules of the rod will vibrate and transmit some part of energy to the next molecule. So the heat energy received by the rod molecule will be utilized in two ways. Some part of heat energy is utilized to increase its internal energy. Some part will be transferred to the other. Clear? So as the heat energy transmitted from one part of the rod to other part of the rod, what happened? Some amount of heat energy will be received by the one cross section and remaining part will be transmitted to the next part. As the time passes, what happened? The temperature of the every cross section goes on increases slightly. Here temperature increases to T1. Here temperature increases to T2. In some other place temperature becomes T3, T4 like that. After reaching T1, T2, T3, T4, the temperature of these cross sections does not increases further. They remains constant. After reaching this state, how much amount of heat energy is received by this cross section will be transmitted to the other cross sections. This state is called steady state. Previous state is called variable state. Clear? Here I considered one rod. A rod is divided into several cross sections. This is one rod. This is the cross sectional area A1. This is the cross sectional area A2. This is another cross sectional area A3, A4 like that. So I am supplying heat energy to the end A1. Clear? This end A1 receives some Q1 calories of heat energy. Out of Q1 calories of heat energy, some amount of heat energy is increased to its temperature. Some amount of heat energy is transmitted to the other cross sections. In such a situation, temperature of the each cross section slowly increases and reaches a constant values. The temperature of different cross sections may have different temperatures, but after reaching the particular state, their temperature remains constant. Such state we are going to call it as steady state. Clear? After the rod reaching the steady state, how much amount of heat energy received by the one end, that much amount of heat energy will be transmitted to the other end without utilized to increase its temperature. This state we are going to call it as steady state. In steady state, how much amount of heat energy one cross section will receive, that much amount of heat energy will be transmitted to the other cross sections without absorbing. That state we are going to call it as steady state. Previous state, where some amount of heat energy is utilized to increase its temperature, is called variable state. During the variable state, temperature of the each cross section changes with time and remains constant after reaching certain values. That constant state we are going to call it as steady state. Students, are you able to understand what we are going to call it as steady state, what we are calling as variable state? In steady state, temperature of, so no one is responding. What is steady state? What is variable state? Tell me.
All the temperatures are constant, sir.
Temperature of each cross section of the rod remains constant. So in steady state, the temperature of
All the area of cross sections
two
has the same
different
temperature.
cross sections,
Yes, sir.
two different
Are constant.
cross sections of the rod may be different, but temperature of the each cross section, temperature of each cross section is constant. Clear?
Yes, sir.
That state we are going to call it as steady state.
Steady state.
The temperature of cross section decreases when we move from hot end to cold end. Temperature decreases when we move from hot to cold end. Clear? So the rate of flow, so temperature gradient we need to define one more term, we need to define in order to understand the conduction. The rate of flow of heat through every cross section remains constant. Rate of flow means what? Rate of flow of heat means what? Amount of heat energy flowing per unit time through every cross section. We are going to call it as heat current or rate of flow. Heat current or rate of flow of heat energy. Heat current means amount of heat energy flowing per unit time through each cross section. In steady state, heat current is constant. Steady state heat current Q by T. In some books it is represented with a letter H, which is equals to constant in steady state. This is about steady state. So I think in your previous classes you may learned about temperature gradient and voltage gradients like that. What is gradient? Tell me. How will you define gradient? Temperature gradient. How we are going to define?
Rate at which temperature changes as we move.
Change in temperature per unit length across the rod is defined as temperature gradient. Clear? If the temperature, for example, this is the rod. One end of the rod is kept in water bath. This is a water bath, hot water. Clear? Other end of the rod is kept in ice bath. This is ice. This is ice bath. The temperature of the melting ice, we know it as 0 degrees Celsius. Temperature of the hot water is, let it be some T1 degrees or T degrees Celsius. Clear? Let the ends, distance between the two ends is x. So how will you define temperature gradient? Tell me. The temperature, if the temperature of this is T1, let it be 0 degrees as T2. Temperature difference is how much?
T1.
Temperature difference is T1 minus T2. Am I correct?
Yes, sir.
Yes, sir.
Temperature gradient, how you are going to define? T1 minus T2 divided by X. This is the temperature gradient. So what is the unit of temperature gradient? SI unit is
Kelvin per meter.
Kelvin per meter. What is the Celsius unit? So generally we are going to express the temperature in degrees Celsius. Am I correct?
Yes, sir.
Temperature is in degrees Celsius. So practical unit is
Degree Celsius
Degree
is
0
Celsius
centimeter.
degrees Celsius per meter.
per meter. Yes, sir.
What is the conversion factor for Kelvin scale and Celsius scale?
Kelvin equal to Celsius plus 273.
That is the temperature. Temperature difference. This is lower fixed point for Kelvin scale. 0 Celsius scale is 0 degrees. Upper fixed point is 100 degrees. Am I correct?
Yes, sir.
Lower fixed point is melting point of
Melting.
ice. Upper fixed point is the boiling of water, temperature at which water boils. Clear? In Kelvin scale, this is 273 and 373. 100 degrees Celsius change in temperature is equals to 100 degrees Kelvin change in temperature. That is why 1 degree Celsius change in temperature is equals to 1 Kelvin change in temperature. There is no conversion fact. 1 degree Celsius change in temperature is equals to, even though if you mention temperature in Celsius scale or Kelvin scale, the value becomes same. Clear? So let us suppose that if the temperature difference is here very less, this is 30, this is 0. Clear? In such a situation, Q levels of heat energy or Q1 levels of heat energy will flows through the rod. Students, please mute yourself. Don't create any nuisance here.
Sir, can you repeat?
Let us suppose that I am going to consider two situations. In one situation, the temperature difference is only 30 degrees. In some other situation, hot water temperature is some 50 degrees. Here, temperature difference, here ice temperature is 0 degrees. In which case, more amount of heat energy will flow from hot end to cold end.
50 degrees.
So if temperature difference is more amount of heat energy will transfer. Am I correct? Amount of heat
Yes,
energy
sir.
flown per unit time is defined as heat current. This is heat current. Heat current is nothing but heat energy flowing per unit time. Is directly proportional to temperature difference. Will you agree this or not?
Yes, sir.
If this length is very large, in one case length is very small, 100 centimeters, in another case only 10 centimeters. 10 centimeters. Clear? So in which case more amount of heat energy will transfer from longer end to hotter end to colder end. In which
10
case
centimeter.
10 centimeters case more amount of heat energy will transfer. Why? Because loss of heat energy to the surroundings will be less in case of distance between the two ends is less. Will you agree this or not? So amount of heat energy transferred is directly proportional to temperature difference, inversely proportional to length.
Length.
I considered two rods of same length but different cross-sectional areas. Clear? One is in hot, one end is in hot region, another one is in the cold region. This cross-sectional area is A1, this cross-sectional area is A2. Heat energy passing per unit time in first rod is H1, in second rod is H2. In which case, more amount of heat energy will flow, tell me?
H2.
H2. Let us assume that it is like a tube. One tube has more cross-sectional area, another tube has less cross-sectional area. Clear? We are maintaining same pressure difference between the ends. Then what happened? So I
Sir,
think
A dash
fluid mechanics chapter is completed. Rate of means volume of the water flowing per unit time. Am I correct? In which case, more volume will flow from one end to other end.
more cross
The
section.
pipe which has more cross-sectional area, through that pipe, more amount of water will flow. Am I correct? Heat energy is not only depends upon length, it also depends upon the cross-sectional area. If cross-sectional area is more, transfer of heat energy. If I join all these things, if I combine all these three equations, what we are going to get? Heat energy is directly proportional to A T1 minus T2 by
L.
L. In order to replace this proportional, let us consider two identical rods. One is prepared with iron, another one is prepared with wood. So both ends are maintained at same temperature difference. So will they transfer same amount of heat energy or different amount of heat energy? Tell me.
Different.
Different. Why?
amount of
Because Why? Because
Material is
Material and
transport
wood.
energy not only depends upon their dimensions, and temperature difference, it also depends upon the nature.
Material.
Nature, am I correct? In order
Yes,
to
sir.
replace the proportionality, we need to require a proportionality constant. That proportionality constant, we are going to call it as coefficient of thermal conductivity of the given material. Clear? It does not depends upon the shape. It does not depends upon the temperature difference. It depends only on the nature of the material of the rod. Clear? How you define what is the SI unit of heat current? Tell me. SI unit of heat energy is joules. SI unit of time is seconds. Joule per second is the SI unit of heat
It's a
current.
unit of. Yes, sir.
Joule per second is nothing but what? Am I correct? Joule per second is work done by unit time. That is nothing but power. Power unit is what?
watt.
Watt. Clear? The SI unit of heat current is watt.
Watt.
Clear? Oh, what about K unit? Tell me. Watt meter by meter square to Kelvin. Am I correct? Watt meter inverse Kelvin inverse is the SI unit of coefficient of thermal conductivity. Is it clear? I think how many of you know about uh, electric current Ohm's law? What is Ohm's law? Tell me.
V is equal to IM.
V equals to, here I is called electric current. Am I correct? If I compare heat current with this equation, here potential difference is equivalent to temperature difference. Clear? So here heat current, how much we got? Tell me. K into A into
T1 minus T2
delta
by
T divided by L. Am I correct? If I rearrange this, delta T by L by K. Is it clear? If I compare this, in place of R we had L by Ka. This L by Ka we are going to call it as thermal resistance. Clear? This L by Ka we are going to call it as thermal resistance. If the two rods, two resistors are connected in series, what is the equivalent resistance in
R1 plus R2, sir.
R1 plus R2? Is it clear?
Yes, sir.
So like that here also, if the two rods are connected in series, R equivalent is how much? R1 plus
R2.
R1 plus R2. R1 is how much here? This is one rod whose length is L1, whose thermal conductivity is K1, whose cross-sectional area is A1. Clear? This is another rod whose length is L2, whose area is A, whose thermal conductivity is K2. What is the R equivalent here? Like in resistors, R equivalent is R1 plus R2. R is here L1 by K1A plus L2 by,
L2 by K2A.
if you connect two rods in parallel, this is K1, cross sectional area is A1, length L. Here K2, cross sectional area is A2, length L. In such a situation, if the resistors are connected in parallel, what is the R equivalent? How will you calculate R equivalent?
1 by R1 plus 1 by R2.
1 by R1 plus 1 by R2. Here R is how much?
A1 by and K2 A2 by
R is equals to L by Ka. Am I correct? This is the thermal resistance. So let us suppose that this is the rod. This is the rod. This is the hot region. This is the cold region. In steady state, the temperature of the hot end is T1. Temperature of the cold end is T2. Length of the total rod is capital L. Length of the total rod is capital L. Is it clear? At a distance x meters from the hot end, they asked to calculate temperature T. How will you calculate? Tell me. How will you calculate this temperature at B? This is A. This is C.
So T1 minus T2 by uh, total length is
In
equal
steady
to
state, I said that heat current is same. Am I correct? Heat current, how you are going to express? Tell me.
that T1 minus
Ka
T2 by
into T1 minus T
T2 by
divided by
L, sir.
by
X.
L.
L.
Here
Yes,
L is
sir.
X.
Okay, sir.
Yes. Which is
Similarly,
equal
Ka
to
into
K
T minus T2.
T1
T minus T2 by X.
Here length is
L
total
minus X.
L minus X, sir.
L minus X. Am I correct? Here
Yes, sir.
Ka gets cancelled. From this relation,
Yes,
are
sir.
you able to get temperature at a distance x meters from the hot end? Tell me how it is. T1 minus T by X is equals to T minus T2 by L minus X. If I cross multiply, what we are going to get? T1 minus T1 minus T2 by L into X we are going to get. So if I try to draw the graph between the temperature of the various cross sections from hot end to cold end. So what happened? This is in the form of y equals to minus mx plus c. Am I correct? I am drawing the temperature versus distance graph. This is the cold end. This is the hot end. Hot end temperature is T1. Cold end temperature is T2. It is decreases linearly from one end to the other end. Is it clear? So radial flow of heat. Let us suppose that this is the two concentric spherical shells. How heat will flow radially? Consider two thin spherical shells of internal radius R1, external radius is R2. Here there is a matter, man. So on subject this here. Here in this region, there is a material medium whose thermal resistance is some K. Whose thermal resistance is K. Here at the center of the hollow spherical shell, we kept some heater. Here I kept some heater. Clear? So now heat will flow like this. Heat will flow like this from center to radially away like this. So we need to derive the expression for heat flow. In order to derive that heat flow, we are going to consider one elemental portion like this. Let us consider a small elemental portion which is at a distance smaller, whose thickness is dr. Across this, temperature is decreased to delta T. Across this small spherical shell, the temperature decrement is let it be delta T. What is the way to express the heat current? Tell me. Through this shell. Heat current through this shell is Ka into minus dt by dx. Here dt by dx is temperature gradient. dt by dr. dt by dr. Here A is what? Cross-sectional area of the shell. This cross-sectional area of the shell is 4 pi r x square. If I substitute heat current, we are going to get like this. Here negative sign indicates that as you move from the inner surface to outer surface, temperature decreases. Is it okay? dt value is how much here? dt only. Area, we need to express it as 4 pi r square dt divided by this thickness is only dr. If I rearrange this, we are going to get like this. dr by r square is equals to minus 4 pi k divided by h into dt. H is the power of the heater. Power means what? Heat energy supplied per unit time. We are going to call it as power of the heater. Power of the heater is, let it be H. Power of the heater or the rate of flow of heat coming from the heater is, let it be H. H is nothing but Q by T. This is nothing but power of the heater. Q by T is the power of the heater, which is constant for the given heater. If I integrate this between the limits, lower limit is R1, upper limit is R2.
R2.
Let us suppose that in steady state, the temperature of the lower shell is T1 and temperature of the outer shell is T2. So if I integrate, what we are going to get? Tell me. R power minus 2 plus 1 divided by power rule. How many members of you know integral x power n dx? Is it okay?
Yes, sir.
4 pi k by h into integral dt. Integral dt is t. Integration limits are
T1.
so if I apply limits, what we are going to get?
Into T. Yes, sir.
Minus 1 by r. Limits, after substituting limits, what we are going to get? What we are going to get? Anyone please? 1 by r1 minus 1 by r2. We are going to get like this. Am I correct?
Pi and pi can cancel. Sir, pi and pi can.
Pi H.
This is h, not pi. Clear? Denominator, it is h. Power of the heat.
Okay,
From this
sir.
relation, we can able to get thermal conductivity as h into R2 minus R1
R2 minus R1.
divided by 4 pi R1 R2 into
R2.
steady state temperature.
T1 minus T2.
This is the way to express radial flow of heat. So by using this concept, previously they asked one. So there is a two vessels. These two vessels contains some liquids, different liquids. This liquid temperature is T1. This liquid temperature is T2. This is
T2.
liquid. These two are joined by a rod whose length is L. Cross-sectional area of the rod is A. Whose coefficient of thermal coefficient is K. If T1 is greater than T2, if T1 is greater than T2, these are closed. The thermal loss is not occurring to the surroundings. Thermal radiation loss is not occurred to the If T1 is greater than T2, after how much time the temperature difference reduces to half, they asked previously in one INO examination. If T1 is greater than T2, so heat will transfer, am I correct? Heat will transfer from the liquid 1 to liquid 2 until their temperature becomes equal. Am I correct or not? After how much time their temperature difference will be reduced to half of the initial temperature difference, they will ask. How we are going to solve this one, tell me? In order to solve this type of problems, along with the heat transfer, so we need to require calorimetry concept also. So whenever heat is supplied to the block of mass m, its temperature increases, am I correct? From T1 to T2. How much amount of heat energy we need to supply, tell me? Q equals to ms delta T. Yes, we are going to call it as specific heat capacity. M is mass. Delta T is change in temperature. Am I correct or not? If there is a state change takes place, instead of ms delta T, we are going to use ml.
Tarak sir.
Sir.
Sir, last 5 minutes.
So, okay, sir. Next
sir.
వేరే సెషన్ ఉన్నట్టుంది కదా.
Yes, sir.
సో ఓకే సార్. సూరిబాబు గారు.
Excuse me, sir.
సార్.
Sir, can you send a screenshot of the notes?
సార్ గుడ్ ఈవినింగ్.
గుడ్ ఈవినింగ్ సార్.
బాగున్నారా?
బాగున్నాను.
ఓకే సార్, క్యారీ ఆన్ సార్, క్యారీ ఆన్.
So okay sir, I will wind up in 2 minutes. Students, do you want screenshots?
Yes, sir.
Just give 5 minutes for doubts clarification, sir.
Okay sir. So doubt clarification అంటే ఈరోజు వీళ్ళు చాలా